For question 12 in module 1, you're asked to use the composition of two functions to determine if they're inverses of each other. So for this problem, I have two different examples to show you so that you could see one case where they are inverses and one case where they are not inverses. Okay. So with this, what we're trying to do here is when we talk about the composition of two functions, that's really just saying f of g of x, okay? Or it's saying g of f of x, okay? And so when we look at that, let's just look at the f of g of x first. So that's really just saying when I take my f function, everywhere I see an x, I'm going to substitute in for it my entire g function. Okay, so that can simplify a little further. My g function here, we could see g function is really 1/3 x minus 2. So what that's saying is everywhere I see an x in my f function, I'm going to substitute in this 1/3 x minus 2. Okay, so that means I'm subbing this in to this x. Okay, so that gives me 3 times my x. So I'm going to sub in this 1/3 x minus 2 for that x plus 6. And now I want to simplify. When I simplify, I'm multiplying this 3 to both terms, and I get 3 times 1/3 x is x, and 3 times -2 is -6, and then I have this +6 out here. So I'll see the -6 and the +6 cancel with one another, and that leaves me with x. And by definition, if the composition of two functions is equal to x, then they are inverses of one another. Okay, so we've done this. We've done the composition of f of g of x, and we get x, so that's a good check mark there. But we need to just verify with g of f of x to make sure that it works both ways. And so for g of f of x, this is going to give me g, and everywhere I have an x in my g function, I'm going to substitute in my f of x function. So that is g of 3x plus 6. Okay. And so everywhere I see an x in my g function, which that occurs right here, I'm going to substitute in that 3x plus 6. So that gives me 1/3 times 3x plus 6 minus 2. Okay, so I'm going to distribute this 1/3 to both terms inside that parenthesis. So 1/3 times 3x gives me x, and 1/3 times 6 gives me a +2. And then I just write the remainder of that problem here, which is the -2. And I could see that +2 and -2 will cancel out with each other, and I am left with an x. So I could see that the f of g of x gives me x, and g of f of x gives me x. So these two functions are inverses. Okay. Now let's look at another example. Same problem, just a different, or same Mobius problem, just a different look at the example. Okay. So let's look at our f of g of x. Okay. And so that is, again, as I explained, we're just everywhere we see an x in our f function, we're going to substitute in our g function. Okay. So this gives me, I have one x here, so I'm going to substitute in my g function for that x. So that's 5x plus 1. And now I just write the rest of it exactly how it is. Okay. And so we'll simplify this. This gives me 5x plus 2 over 5. And I can't really easily simplify that anymore. So chances are that's not going to simplify down to equaling x. So this does not equal x, therefore it's not an inverse. But I want to also show you how we could have done it in g of f of x as well. But know that once you get one of the compositions not equal to x, then it's not going to be a function because they must both be equal to x once you do that composition. Okay, so g of f of x, everywhere I have an x in my g function, I'm going to substitute in my f function. So I have an x right here. So I'm going to say 5, and now I'm substituting in my whole f function. So that is x plus 1 over 5. And then I have that plus 1 out there. Okay. So the 5s will cancel with one another, and that's going to leave me with x plus 1, which is x plus 2, and that is not equal to x. So these two functions are not inverses.